Hi, everybody. I need just a moment before we get started here, so I'm going to keep the music going. And I'll be back in like 2 or 3 minutes, so I apologize for the delay. All right, I apologize for that. I had an issue with my bank here. Part of the problem of having a credit card is that every like 3 or 4 years your credit card just gets the number just gets stolen. Like there's nothing you can do about keeping it safe online if you're using it to purchase or auto pay or whatever. And unfortunately that's what I'm going through right now. And I got a notice from the internet that they were like, or the internet company saying, "Hey, your auto payment didn't go through because your credit card is no longer valid." Like, yeah, I know. Here, let me quickly pay that so that my lecture doesn't die in like I don't suddenly just go offline in the middle of streaming. That would be really bad. So I had to immediately take care of that and be like, okay, I do have money. Here it is. Just had to use a debit card to do it. Today is a lab lecture, which means that we are going to be discussing lab worksheet number 2. To answer the question that's in the chat, today is the last call for quiz 2. I'm going to send out that announcement when I have a second to do it. Been a little busy. Quiz number 3 is also due next week, so make sure you get that in by the deadline. There shouldn't be anything on the screen, so I mean, I could do this. Oh, that's all my organic chemistry. That was what we're doing in my first class, so if that looks like Greek to you, don't worry about it. It's gone. I do want to capture, though, this window. Boop. There we go. All right, so let's see here. We only need that much. So if you click over here and go to lab worksheet number 2, it will take you to this page. And if I open the... Oh, I didn't open the PDF. Let me do that. Lab worksheet number 2. Cool. Yeah, I have a chip in mine too, but because just typing in the number and the security code online is just what you have to do, there's nothing that can be really done about it. Like, I do almost all of my shopping and payments. Like, I don't use a checkbook anymore. Like, who uses checkbooks? And like my card was going to expire in June of this year, I think, and it's very rare that I get to the end of a card's lifespan because it's always like at some point it's going to get stolen, but somehow. I've never lost a card, but it's always just been like, oh, someone online has guessed your number, or they downloaded it from some other place, and like, yeah, what can you do? Yeah, that's BS. Like, people online shop all the time. It's not your responsibility to keep your card secure. It's the seller. And they don't, and that's obnoxious. This is too tiny. There we go. Okay. Lab number 2 is about density. You're going to be doing a series of, not really experiments. You're going to be doing simulations here. We'll get to all these tables in a second. As you can see in this worksheet, I give you a lot of formulas. Please read the documentation. The formulas will tell you how to do stuff for each part. What's important for this is that it's going to be split into 4 different parts. So if I go like this, and you look at the bottom, which you can't actually see, you'll see at the bottom it says experimental part A, part B, part C, part D. So you just go to the right part and fill in what it is asking you to do. I use names of people in the lab and then refer to them in questions. Please be careful that you are answering the question asked. So for experiment 1 here, Ava is doing this experiment with this data, and then these questions ask about her experiment. Then down here, we have Contessa, who does this experiment, and this information asks about her experiment there. Make sure you are not mixing up who is doing what experiment. Because if you do, and then later on, like in the post lab, we refer back to these people's questions. So here we got Contessa, we've got Ahmed and Greg, and I have random names of people in the experiment that are referred to. So this is something that happened the last quarter where people just started answering whatever question they wanted to. And I'd be like, well, I gave them a name specifically for that purpose, so you could go back to their experiment. So just be mindful of that you are doing the experiment that's being asked. There are 4 experiments. I forget if there are any videos in this one. I don't think that there are. I'm just looking through real quick. Okay, there's not. So what we're going to do is we're going to start with part A, and I'm going to talk to you about what's going on. In part A, you're going to measure the density of a substance by doing the following. So let's turn this off. You might not have been able to see my PDF, but that's okay. All right. So part A. For a second, my ink wasn't registering. That was kind of confusing. Okay. So you're going to be given a sample of water and a vial. And so the procedure here is that you're going to first weigh the vial, then add a volume of H2O, and then finally weigh the vial with the H2O inside. So the volume that is going to be added is going to be specified. And so the way that we would normally do that is we'd use a pipette. A pipette is a very precise piece of glassware that measures out a certain amount of liquid to many decimal points. So for example, the pipette that we'd be using here would be 10.00 milliliters because it's calibrated that if you use it correctly, it'll dispense that many milliliters to that degree of precision. Now, the whole point of doing this is so that you can do the following analysis here. So if you know the mass of the, not the weight, blarg, hold on. If you know the mass of the vial and the water that's inside it, and then you know the mass of just the vial, and you subtract those two, these would subtract from each other, and what you'd be left with was just the mass of H2O. So I don't know if this was 15 and this, or 0.3, and this was 5.4. There you go. Something like that. If you know the mass of the water that's in there and you know its volume, you can then combine these to get the density. So that's part A. Part A is simply just put some liquid in a vial, weigh the vial with the liquid in it, compare that to the weight of the vial before you put liquid in it. and then use that information to get density. So when you're doing part A, if the sample that is being worked with is water, you have a true value listed here. That value depends on temperature. So example, if you were in a lab and it was 20 degrees Celsius, this would be the density of water, 0.998234. All these are in grams per milliliter. If it was 30-degree water, the density would be 0.995678 instead. We use 5 milliliters. Okay, so. Oh, sorry, never mind. No, we use 10. Okay. For part B, we use a 5 milliliter sample of a different compound that is not water. And your job is to identify what it is based on the data that has been collected. Okay, that's part A. Part A is very straightforward. Part B, what's the difference between volume and mass? Volume is the space an object occupies. Mass is how much matter it has. So when you get something's mass, you find out how heavy it is, for example. So mass is measured in kilograms, and volume is measured in liters. For our purposes, we're going to use grams and milliliters because we want to use something smaller. For part B, you're going to do more or less the same thing, but then you're going to plot your data on a graph. And so the way that this works is we're going to give you some alcohol solutions that are rubbing alcohol mixed with water. So for a 25% solution, 25% of the solution's volume is isopropanol. For a 50% solution, 50% of it's isopropanol. And then 75 and 100 would be 75 and 100% isopropanol. As you do this, you're going to notice that they have different masses. And when you divide by their volumes, you get different densities. Finally, we're going to give you an unknown, which could be any percent alcohol at all. Here's what you do with that information. So first, we're going to go to this guy. We're going to go to page 2. And you're going to notice down at the bottom, it tells you here, create a graph somewhere in this box. So you have this huge box to work with, and the instructions scroll off the side here. So what you're going to do is you're going to follow the directions. So let me scroll those over so you can see them here. So you're going to create a graph using your data. So your data is going to be from these tables up here. You're going to plot what the directions in the lab tell you, which will be the density of the liquid versus its percent alcohol. So I'm going to make some data here. So I'm going to call this first column percent alcohol, and the next column I'm going to call density. And so I'm just going to put in some numbers. So 25, 50, 75, 100, and 0.9, 0.8, 0.7, 0.6. So I'm just making up some numbers here. So then what we're going to do is you're going to follow the directions. So you're going to select in search from the menu up here, and then choose chart. And so it will try and find your data. In this case, it did a pretty good job. I actually have to expand this. So chat's going to hide for just a second here. Let's uncover the directions here. So we're going to go to series. We're going to select the y-axis value for the series. Now, it did what I wanted it to, which was it selected density. So density is the y-axis value. On the x-axis, we're going to put alcohol, because that's what I told it to. Then what I'm going to do is I'm going to go to the Customize tab. That's this right here. And I'm going to add a title and a graph. So under Chart and Axes Titles, I'm going to give this a title. So it defaults to density versus percent alcohol. You could call it whatever you want to. That's probably a good enough title just for this example. But if you want to change it, you can do that. Your axes should have titles on them also. They should also have units. So where are my... Oh, there we go. That's how I do it. So horizontal axis would be the one on the bottom. So percent alcohol is just a percentage. So I'm just going to add that in there. And then vertical axis, density. Density is in grams per milliliter. So we're going to add that there too. You can notice that that's changing how my graph appears here. Then I'm going to go to horizontal and vertical axis. And what I'm going to do is I'm going to change these numbers using this range right here so that my graph spans the whole screen. Now for the horizontal, I want to go from 0 to 100%. So that's fine. In fact, I might want to just make it a little bit bigger so that I can see all of my data. The 0 data point, oh, I don't have a 0 data point. Okay, so everything is showing on the graph, so that's good. If you click on that, I guess the boundaries go away. For my vertical axis, you'll notice that there's all this empty space down here. I don't need anything below 0.5 because no number goes that low, right? So to make this fill the entire graph, what I'm going to do is I'm going to make the minimum 0.5 and the maximum 1. There we go. Now my graph fills the entire thing. Then the last thing that I want to do is I want to add a trend line. And the way that you do that is you go to legend here. Is it not under legend? Maybe it's under series. There it is right there. You go to series and you click on this button down here, trend line. Boop. And it's going to put a line through your data. And then what you need to do is you need to scroll down to where it says label and choose use equation. Boop. And then check show R squared. Boop. There you go. What all of this did, and you can see this on the graph right here, this put a line through our data and then gave the equation of that line. What this says is that our data is related by this equation. -4 times 10 to the minus 3, that's what the capital E means. -4 times 10 to the minus 3 times x plus 1 equals the y value. So whatever value I put in for x, where x is a percent alcohol, which is what I wrote right here, I put x in for this, I times it by -4 times 10 to the minus 3, I add 1 to it. That is the result for my y value. So if I plug in 25, I should get 0.9 out. R squared is a correlation factor that tells you how linear your data is. So for example, if I change this slightly, 0.59, 0.91, 0.72, 0.808 or whatever. You can see that I'm adding error into my measurements. Now it's not a perfect line, and so this is no longer r squared equals 1. The closer you are to 1, the more linear your data is. Whereas if I had something like this, now my data is very poor, a poor match for this graph. Now my r squared is 0.07. So, all right. The last thing you want to do when you are done with your graph is you just want to make it big and put it over all the directions, and you're all set. Now, keep in mind, if you make a mistake over here in your graph, you type any numbers you want in the graph, and it will just edit them on the fly. And obviously, you can get some really funky results in the meantime. So just fill in all of your data and then go refer to your graph. All of the information will update in real time. If you clear your graph, oops, then this happens, and it won't know what to do anymore. So if that happens, you need to erase the graph and start over. You can also just hit undo. So to summarize part B, you are going to find the masses and densities of the liquids just like you did in part A. Then you are going to plot density versus percent alcohol in a graph just like I showed you. Okay. Very, very important. If you are not using Google Sheets, I will not get your graph and you will get no points for it. You have to use this program online to construct your graph. Okay, so don't download the worksheet and then do the graph in some other program. Use Google Sheets. Otherwise, you get a 0. Okay. All right, that's part B. You're going to learn how to make a graph. Making a graph is a really important skill to have for not just this class, but for pretty much every science class you're going to take. In part C, you're just going to do some simple calculations and figure out percent error. So instead of measuring the density by... Oh, excuse me, hold on. I had to yawn there. Instead of measuring the density by adding a volume of liquid, you're going to measure the density by displacement. So here's how that works. So part C. In part C, not Patsy, you're going to have aluminum pebbles. And these are going to go into a graduated cylinder that has a certain amount of water in it already. When you put the pebbles into the graduated cylinder, the water level rises because of displacement. The difference between these must be equal to the volume of the aluminum pebbles. And since you can mass these by just taking them to the balance before you put them in the graduated cylinder, and you know their volume, you can figure out density. Okay, so part C is really simple. Let's just do the calculation based on the information that is shown. Part D is a mathematics problem that is going to require you to understand how to figure out thickness of aluminum foil based on various properties of it. Now, in order to figure out the thickness, you need to know the density. You can find the density right here on page C. Okay, it's right here. I'm pointing at it right now. Because anything made of aluminum has the density of aluminum, whether it's an aluminum pebble or an aluminum foil, you'll need that number to solve this problem, and you're going to do that in the following manner. So if I delete everything and we go part D, oops. Aluminum foil can be treated as a rectangular prism that has a length and a width. That's not a W. But it also has a thickness. And that thickness is going to be very, very, very thin. If I were to find the volume of my aluminum, the volume would be equal to the length times the width. I don't know what's with my W's today. Times the thickness. Now, I could also determine the mass of this aluminum by folding it up and putting it on a balance, and that would tell me how much it weighs in grams. The last thing we know is the density of aluminum. So the density, which is equal to the mass of the aluminum divided by its volume, is equal to this from part C. Well, if I'm trying to solve for this, and I know these variables, I could substitute in V for right here. So that would give me this formula. Density equals mass of aluminum divided by the length times the width times the thickness. And now I know everything in this equation except for t, so I can then do algebra to solve for t. So I'd multiply both sides by t and divide both sides by d to get this. So if you know the mass, the length, the width, and the density, you can get the thickness of the aluminum. But what would the units of this equation be? So let's write out all the units. Every time you do a problem like this, you should be writing out the units when you plug in the numbers. Mass is measured in grams. Length would be measured in centimeters. Width would be measured in centimeters. And density would be measured in grams per cubic centimeter. I need to deal with this fraction problem on the bottom. What happens when you divide a number by a fraction? That is the same as multiplying by what? When you divide by a fraction, it's the same as not 0.5. I think you're assuming that I'm dividing by a half, which I would just want any fraction. What do you do when you divide by a fraction? It's the same process as multiplying by what? There's a specific term for it that I'm looking for. Begins with an R. It's the reciprocal. Very good. So when I divide this problem, I'm going to take away this fraction on the bottom, and I'm going to multiply by, instead, that same fraction's reciprocal. Now I can see that grams cancel, and centimeters cubed divided by centimeters squared, 2 of these would cancel with 2 of these, and I'm left with this. So when I solve for t in this equation, I will get the thickness of the aluminum foil in centimeters, which it's not very thick, right? Aluminum foil, if you have aluminum foil at home, you could go look at it and be like, wow, that's going to be like a fraction of a centimeter. And yeah, it will be. But that's what the number is going to be spit out as when you do this equation, okay? So part D will involve you taking all those numbers and then doing the algebra and finding the dimension of that is being asked. So that would be the thickness. Then what you're going to do is you're going to take your thickness that you've calculated in centimeters and you're going to calculate it in other units as shown. So here I have centimeters, then I want to know it in micrometers, micrometers, and nanometers. Okay, you'll have to do calculations to do that. And then finally, you have a bunch of analysis questions over here. Make sure that you are answering these questions that are answering the question that is being asked and not some other question. Okay, a lot of people messed up on this question because they would look at, I wrote Contessa and then they go back to Ava's question because they looked at part A and they went to the first thing that was there. Other questions had a similar issue that everybody just started referring to other questions, so be careful. The last thing that I want to point out is that anytime you're entering a number in a box like this, so I don't know, let's suppose that you got this as your answer. If that's what I get for my answer, I have formatted these boxes to be plain text so that if I got a number, that ended in 0, it doesn't chop away all those zeros. So the sig fig should be preserved. If you get to a box that is not like that, so let's say you're typing down here and you want to enter this number, but when you hit enter, everything is formatted as plain text. Okay. Well, let me suppose that that wasn't the case. There we go. So I type in 0.3, whatever, like that, and this happens. What do? The answer is you highlight the box that you want to change the number sig figs for, and you go up to here, increase decimal places, and you can add as many as you want. or you can remove them. And if you remove too many, what the sheet will do is it will try to round. So 0.03 will just get rounded to 0 if I do that. It keeps those numbers, though, so it remembers what you typed in. All right, and I'm going to change this back to plain text. So I believe I formatted everything as plain text. What that means is that if you use formulas like this, so this cell is equal to this minus this, it may or may not work depending on the contents of the cell, or if there's not units in there or whatever, okay? So just be mindful of that. My recommendation, excuse me, my recommendation for doing these assignments is always to just do all of the numbers by hand and just type in what you have, with the exception of part B where it tells you to draw a graph. That one you want to use Excel for. Or not Excel, I'm sorry, you want to use Google Sheets for. That being said, if you do understand how to do Excel commands, you are more than welcome to do them. Just make sure you are doing them on this worksheet and not using another program and sending me the XLSX from that. You have to send me the XLSX from this Google Sheet. Okay? All right, let me make sure that I didn't edit anything here, because anything I touch appears on your lab because I was editing your lab. So there you go. That's lab worksheet number 2. The questions are not hard, but there are quite a few of them. And if you aren't paying careful attention to the numbers that are available, you can get tangled up in it pretty quick. So be very careful, and be very, very careful about sig figs. The whole point of this lab is really basically, I'm going to be a stickler for sig figs. Every time you get a sig fig wrong, I will paint the cell yellow. And if everything is yellow when I return it back to you, you're not going to have a very high score. So be mindful of how many sig figs each number has when you are doing the calculations, because a lot of these calculations are set up in such a way that I will know whether you were paying attention to the sig figs rules or not. Also be mindful of whether you're doing addition or subtraction or multiplication or division, because the rules differ between multiplication, division, and addition, subtraction. And if you have any questions about the lab I'm totally able to answer. So throw it in the Discord and say, hey, I don't know if I did this right. Can you tell me? And I will try and guide you through the process. I won't tell you the answer, but I can guide you through it. Other students can also do the same and say, like, oh, that's what I got, or I got something similar. And, like, that's totally fine. I think people were starting to use the Discord today to ask a question about, what were we were just talking about it. We were talking about, like, how to enter numbers into Canvas on the quizzes. I can totally tell you about that. I can't tell you how to answer the questions on the quiz, but, like, stuff like that, that's totally fine. So please do talk about things. And if I can't answer it, I will just keep my mouth shut. So if you ask other people for help on the quiz, I just won't answer it. I will sit there and look at it and be like, oh, okay, can't answer that question, sorry. I might even say I can't answer that until the quiz is over. So please use the Discord is basically what I'm saying here. All right, that's all I got. That's my lab info. So for the rest of the period, we will do a Q&A. If anybody has any questions, we'll go over them. But for now, what I'm going to do is I'm going to put the break card up. So let me get the timer on the screen. And we'll just play Earthbound music for 10 minutes. And there you go. So yeah, post any questions that you want me to go over in the chat, and I'll be happy to go over them. So let me start the timer here. We'll just start collecting some questions, and I'll see you in a bit. Assuming I can find the music. There it is. Say hi. Presley, say hi. Meow, meow, meow. Oh, Kresnik is shy. All right. Oh, I gotta turn this down here. Let me find. I gotta find worksheet. Was it 3? Yeah. Labs, no worksheets. Worksheet 3. I mean, I guess I can have the key open. What was it? Number 5 on worksheet 3. So 1, 2, 3, 4, 5. Okay. So we'll do this, and I'll do that. Oh, I gotta turn this on though. Here. All right. This is the actual distance from the sun to the Earth, by the way, is 50 or 93 million miles. Way back when Who Wants to Be a Millionaire was like new, so like early 2000s. Someone got to the $1,000,000 question, and the question was, how far is the sun from the Earth? And I knew the answer. I was the only one in my family who did. I was also the only scientist in my family, so it's good when you know the $1,000,000 question. It makes you feel good about something, I guess. I don't know. All right. So the speed of light is 3 times 10 to the 8 meters per second. And for light to reach the Earth from the sun takes 500.0 seconds. How far is the sun? Okay. So I need to find a distance, and that distance would be something like this. I know what a speed is, and if I have a time, I can get from time to speed, right? So my goal for this problem is to find the distance in miles. Well, if I can work with the information that's here, I can definitely figure out meters. And then I can figure out how to get from meters to miles, probably through kilometers. And given a time, which is this right here, I can turn time into distance using the speed, which would be 1 second is 3 times 10 to the 8 meters. So let's do this problem. So 500 seconds times the speed of light, 3.00 times 10 to the 8 meters per second, would give me a distance in meters, which I can then turn to kilometers and then miles. So we'll do that. So meters to kilometers, kilometers to miles. So in a kilometer, there's 1,000 meters. That should be a 3. Still doesn't look like a 3. There we go. And I screwed this up last time, so 1.609. I think that's right. Yeah, kilometer's shorter than a mile, so. So 500 times 3 times 10 to the 8 divided by 1,000 times 1.609. 93225 605.97. So I actually got 93 point, or oops. I was just going to say 93.2 million miles, but we actually want to put that in scientific notation. Which should match what's on the screen there, and it's very close. Excuse me. Yeah, don't do that. Make sure that you're getting the conversions from the right spot from Google. I did have a mistake on an earlier video, and I wrote in the comments that that error existed. So just be mindful that you don't accidentally flip those. For the other two problems in this worksheet, you do something very similar. So I do want to let you guys try to do those, obviously. You're going to be given a number somewhere in that mess of information. My advice to you is to do any of these problems, take this sort of approach here that we did, draw all of the information out that you know, and then use that to organize your thoughts. Because the whole point of this is that the problems that I am giving you on this worksheet are in the style of real world problems. Like, you're going to be given a bunch of information, and it'll be up to the scientist, that's you, to figure out what to do with all of it. So, if it sounds like it's sort of an info dump of here's all sorts of crazy shit coming at you, that's just because real life is very, very, very rarely reduced to x plus 3 equals 7, solve for x. Like, that's a gross simplification. So problems 4 and 6 do the same thing. Write out all the information that you have and then make a blueprint. And you should be okay. Anyone have any other questions? Questions about units 4, 5, 6, 7? We haven't gotten to 7 yet. We're on 6. Let me know. I'll give you a minute to type anything in the chat that you want. Anyone have anything else? Last call for questions. Otherwise, I get to go back to grading. And also calling my credit card company to make sure that all these fake charges from Florida and Connecticut that showed up all at once are off my credit card. Why do you convert certain units to other units before, say, kilometers? What do you mean by that? Oh, I just do the conversions that I'm familiar with, but you could use any route to get there that works. Oh, so if you skip the base unit, then you aren't using that prefix table. So remember how we know that these conversions exist? Like, you know that those two conversions exist because they were on that metric to metric table. But there is no conversion from centimeters to kilometers. What you'd have to do is you'd have to start doing mental math and figure out the difference or whatever between these two to do that. So it's just far easier to memorize these conversions from that metric table and then just say, okay, I have this many kilometers. So we'll do kilometers to meters and then meters to centimeters and then just fill in all that information. See, that's really quick. The main reason is that you do it this way and you get into the habit of doing it this way every time and you won't make a mistake. Whereas if you have to go between two different units, or maybe you go from kilometers to nanometers or micrometers to megameters, And then you have to start memorizing all of these different possible combinations, and it gets ridiculous really quickly. Whereas if you just remember the numbers associated with these, then you could just use this template to do whatever you need to, and it's much simpler. We can't ask questions about the quiz. Yeah, I can't answer any specific questions about quiz number 2 or 3, since they are still open. Like, if you ask me how to format an answer, I could do that. But if you ask me, like, hey, can you tell me how to solve how many coins are in this pile of gold that this orc might have? No, I can't do that. That's the whole point of the quiz. Other questions, let me know. I try and answer Discord questions whenever I see them. So, the only day that I'm really unavailable to answer them is Tuesday. Because I start lecturing at noon, and I'm not done until 7 or 7:30 p.m. And so if you ask me a question at like 11:30 a.m. on Tuesday, you won't get an answer until like 8 p.m. because I just don't have time to look at it. But like right now, what I will do as soon as this lecture is over, um, I will go check the Discord. I will check my email. I will then do whatever it is that I was planning to do, which would be, in this case, I'm going to upload your labs and grades. Um, then I'm going to call the bank. That's not something I normally do, but things like that. So if I have a moment, I use it to try and I just quickly check stuff. Um, but on the weekends, that counts too. There might be periods where you can't reach me because I might be playing like Civ 6 with a friend or sleeping or things like that. But I do try to answer things whenever students have questions. So if you have any questions, answer or ask them in the Discord. Let me know. All right, I guess if there aren't any more questions for what's going on in the class here, then I guess we'll just go head over here and we'll call it a day. Oh, there comes the music anyway, so. We'll continue with Unit 7 tomorrow in lecture, so I'll see you then for that. Have a good week.